Seems like it takes a few seconds to start all right.
Okay, we're
And
live.
we're live. And it looks like we've a bunch of people here. I see 62 people.
Fantastic. That's good to hear.
So if you, let's see, I'm trying to enable the chat. If you're here, why don't you just introduce yourself so that we know that everyone can see us? My chat window actually this is a new time. This is the first time I'm using this webinar software, and all of a sudden my chat box has disappeared. Do you see the chat box?
I've got the chat box. Yeah.
Okay,
I
so,
see a little message that says welcome.
okay.
I got a message from Doug.
Okay, great. So the chat window does seem to be working. And there we go.
So it says, I can see you in YouTube, but not in live webinar.
It asks
Playback has been disabled by the video owner message.
Doug, are you able to see us?
It says, can see in YouTube, but not. Huh.
Well, I certainly didn't click any button to disable it. There's a link in, so I'll have to ask them support after they're done. But like I said, this is a new webinar software for me. The big advantage of this software is that it makes watching replays much easier than other software. As long as you can watch the presentation and chat, I think that will continue. Does that sound good for people? The most important part is the presentation that Kyle's going to give and your ability just to ask and interact with the chat box.
Yeah, so long as people can see it. So it looks like everyone's saying that it works fine on YouTube.
Okay, great. Great, yeah, I'll have to submit a tech support request on that so that the next webinar doesn't have that problem. Oh, great, someone actually has the link right there. Good. So that's great. I just want to take a minute to introduce Kyle before he begins the presentation, and to, in particular, introduce the Tigris package, which he created, and he'll be talking about. A lot of people here are familiar with Choroplethor, which is an R package I wrote for mapping any sort of data really easily, but especially US Census data. And if you've taken my free course, Learn to Map Census Data in R, then you've been guided along some of those exercises. When I created Choroplethor, it became popular because it packaged up some maps like US states and US counties. Those maps are frequently packaged up. It also included US zip codes or ZICTAs, and the census tracts from California. And I quickly realized there was this infinite demand for more census maps. And it just wasn't practical to fill that demand by packaging up more and more census maps. And what Tigris does is let you get those maps directly from the census via their API. So it solves a really big problem that users of Choroplethor had, which is how do I get such and such map into R from the Census Bureau? And with that introduction out of the way, I'd like to just turn everything over to Kyle so he can give us a tour of the Tigris package.
Okay, fantastic. And thank you for the invitation to discuss working with geographic data in R today from the census. And I'm going to switch over to the screen share so we can start taking a look at the presentation. So it'll be a mix of, and so we'll have a mix of kind of live coding in RStudio. So just make sure we go back and forth between the two. And get all this, some of these windows cleaned up. Perfect. All right, so first and foremost, I know many of you will like to follow along and play around with the code yourselves. And so this presentation is hosted online on my website, on my GitHub Pages website. There's the URL. Plug that into your browser if you want to follow along with the presentation right now. Also, all of the materials and the presentation itself and the R Markdown that was used to create the presentation is posted in the webinar's GitHub repository. There's the link for you. If you don't want to type all that in, you can just search for my GitHub page and you'll see it's the most recently updated repository. So feel free to hop in and take a look at it. One thing as well inside of that GitHub repository in the R folder is an R script called examples.r, and that includes code for all of the examples that are used in this demonstration. Some of the packages use the development version and as such need to be installed from GitHub. We're going to be working both with functionality in Tigris in the CRAN version and in the development version. So take a look, get those packages installed if you want to follow along. Also, I want to draw your attention to my recently published article in the R Journal about the Tigris package. And many of the examples that I'll be covering today come from that publication. So if you want to revisit some of these examples, try them out for yourselves, read a little bit more about the package than what I'm going to cover today, feel free to take a look at that article. And importantly, just have to mention this disclaimer, this webinar and the Tigris package, it uses Census Bureau data, but it is not endorsed nor certified by the Census Bureau. So moving ahead here, just a little bit of background about the Tigris package, why I originally wrote it, and what it seeks to do. The Census Bureau's core geographic product is the TigerLine shapefiles, and TIGER is an acronym for Topologically Integrated Geographic Encoding and Referencing Database. And TigerLine shapefiles, you have sort of the cartoon graphic here of the tiger, and hence the name Tigris. Naming packages is difficult. The name tiger was taken, so I went with the scientific name for tiger, Tigris. And so TigerLine shapefiles make available a variety of types of geographic information that the census uses to tabulate information, and then also sort of ancillary geographic features that are useful to practitioners who are working with data analysis and map making in, say, a geographic information systems environment or a broader spatial analysis type environment. And so I originally wrote the Tigris package in 2015, and my key collaborator, Bob Rudis, was essential to the development of this package, introduced a bunch of functionality that I had hoped to get to eventually, and he was able to get that done much quicker than I would have been able to. In my work as a geographer, I work a lot with census shapefiles. I found myself going into the census website, downloading them all of the time. And I was encouraged on Twitter through some conversations to think about, could this process be automated in R? Could it be wrapped in an R package? And I was just learning package development at the time, reading Hadley Wickham's book on R packages, and decided to give it a go. And so I'll get into the functionality of the package a little bit more in a second. what I want to go over is just some basic terminology that we're going to be discussing today. In particular, many of the data sets that you can obtain through Tigris are part of the census hierarchy, and you can see it here on this slide. Basically, the census enumerates data at a variety of different geographies, and then allows us to pull data from the census that's aggregated to these geographies. In the core hierarchy, you can see along this central axis here, the smallest level at which we can access aggregate census data is the block level, which in a city is going to be analogous to a city block. Census blocks then nest, which means within the next group of the hierarchy, I should say, census blocks nest within block groups, which means block groups are composed entirely of blocks. Block groups then nest within census tracts, which is a very common enumeration unit that's often used to approximate neighborhoods in spatial analysis. Census tracts then nest within counties, which nest within states, which nest within divisions, regions, and then the nation, the entire United States, is the largest unit at which the census tabulates data. There are a variety of other enumeration units that we can work with here, from congressional districts to zip code tabulation areas to voting districts to urban growth areas. And so these are not part of the core census hierarchy, in that they don't necessarily nest within other enumeration units cleanly. For example, there are some zip code tabulation areas that cross state boundaries. There are going to be some school districts that cross county boundaries, that kind of thing. And so this gives a general sense of what census geographies are like. And so the Tigerline database, you can get these geographies in addition to a variety of other features. And so the census distinguishes between legal entities and statistical entities. Legal entities are going to be aerial units that have some political meaning to them. So it could be a county. A county has a governance structure, has a legally defined boundary, that kind of thing. And so the census tabulates data at the county level. The census also defines statistical entities, which don't have any legal standing, like census tracts, but are nonetheless used to tabulate data. Additionally, in the Tigerline database, the census makes available geographic features. This might include roads, this might include rivers, so linear and aerial water features, railroads. So these are additional data sets at which we don't tabulate statistical or demographic data, but are useful to use, say, in a map making or analytical workflow. And so generally speaking, the way that I traditionally accessed Tigerline shapefiles is through the drop-down menu interface. And if you have the slides up on your screen, you can click through to this link. And so basically you walk through a series of drop-down menus, you select the year that you want, you select the geography that you want, you might have to subset for a state or a county. And this workflow, it's the common way that you access data from the web oftentimes, but it can be a little bit cumbersome, and it's certainly not a reproducible workflow. Another way to do it that is slightly more reproducible is that you can download these files directly from web or FTP interfaces from the census. And so each data set in the Tigerline database is made available as a shapefile, which is a very common way of encoding vector geographic data. And what you can do is say, go through here and take a look at, this is census tract data. And the census tract data is made available by state. And the states are delineated by their FIPS code. So 01, that refers to Alabama, 02 to Alaska, so on. And so to use this successfully, you could download the data inside of your R script, certainly, if you knew exactly which FIPS code to use, and you could go certainly and find it, and this is how most people do it. But given that there is a consistent naming structure in these links, when I first started developing Tigris, I thought, could we make it easier for our users to directly talk to this website, pull data into R, and then load it into R? in a single line of code. And so that was really the impetus for Tigris, to try to create a framework that, I suppose, first and foremost, made it easier for me to be able to kind of augment my workflows, get data whenever I wanted. Let's say I wanted census tracts for a county in Texas. I wanted to be able to type in the county and get it, rather than figure out what the FIPS code for the county was and then go get that data set from the web. And so first started working on Tigris in 2015, and with the collaboration of Bob Rudis, really got this package ready for CRAN submission. So it's been on CRAN for probably about 1.5 years now. And recently I've made some updates to it as well that adds support for simple features. And so I'll explain exactly how all this works in a second. Some of you are probably more familiar with spatial data in R, and some of you might be less familiar. So I'll give a bit of an overview here. So to get started, if you have Tigris installed, I'm going to be working with the development version available from GitHub here. You can also work with the CRAN version. That'll allow you to run, at the very least, most of the examples today. And so we can fire things up and type library Tigris into your R console. And so one thing that I do want to show you is I've got, RStudio fired up here, and I have this example script, examples.r, that includes all of the code that's available on the slides. And so if you have that script up, you can run that code along with me. So on a basic level, what Tigris allows you to do is call a function that corresponds to a given census geography, like states, and then assign the result of that function to an R object, generally speaking of class spatial data frame. And so Tigris functions will return objects from the SP package, so of type spatial polygons data frame usually, spatial lines data frame, or in some cases, spatial points data frame. And so a basic function call here is just calling the function states, assigning that to the variable named US, and then plotting that R object. And what we see here then is the result. We have a data set, a spatial polygons data frame of states in the United States. And so running that code inside of RStudio, you can find your slide 11. We run that code. And R will plot that for us. Now, one thing you didn't see happen is, at least on my screen, but what you'll likely see happen when you use Tigris for the first time, is you will see Tigris download your data. And so Tigris works sort of as explained on this slide. When you call a Tigris function, what it does first is it sends a request to the US Census Bureau website, depending on the arguments you've supplied to your function call. It downloads your data from the website and then stores that data by default in a user cache directory, which is identified by the raptors package. There are options that you can specify if you want to download the data every time. There are options that you can specify in Tigris to do that, but by default, you only have to download the data the first time. And this is often what's going to be the most time-consuming part of your Tigris function call, because some of these data sets, especially when we're talking about, say, census blocks, can get very, very big. So the download process sometimes can take a little bit of time. But the nice thing is, because Tigris caches your data, and this is all credit to Bob Rudis, who wrote the code to do this, you only have to download it once, and then Tigris will know that you already have that data set in future R sessions and look in your cache directory to load it in. And so once that data has been downloaded, Tigris will use RGDAL by default, the read OGR function, to read your data in as an object of class SP, or and we'll talk about this toward the end today, in the development version of Tigris, you can use the SF package. The stRead function under the hood will read in as an object of class SF, or simple features, the next generation of spatial data in R. And so I want to give an overview now of some of the functionality of the package. So one thing that Bob and I incorporated into the package when we wrote it was smart state and county lookup. As I mentioned, sometimes it can be cumbersome to look up even a state FIPS code, or even if you have those memorized. Rarely do we have all of the county FIPS codes memorized. And so we use lookup tables under the hood in Tigris to allow users to specify, say, the state postal code or the state name, so RI, say, for Rhode Island, in place of the FIPS code that's used to identify the data sets on the census website. Now, Tigris allows users to access the core Tiger line shape files, but also cartographic boundary files, which are simplified versions of the Tiger line files that are clipped to the shoreline of the United States. And in many ways are preferable for thematic mapping because the object size is smaller in many cases. And so we show an example here of the differences between the different types of data sets you can get. The core Tiger line shape files, we make a call to counties for Rhode Island. We want counties in Rhode Island. Or we can create a second object, RI20, in which we specify CB equals true, telling Tigris that we want the cartographic boundary file at a resolution of 1 to 20 million. So the most simplified version available from the census. We can then plot the data sets on top of each other and see the differences here. And so we can go back to RStudio and plot that. We pull in our core Tiger line data set. We'll get a little message that we're using FIPS code 44 for the state Rhode Island. And we see the differences here. The red represents the simplified file. You see how it's been clipped to shoreline, but there's far less detail in the interior. And so ultimately, you can decide which data set is of most use to you when you're planning your cartographic or analytic workflow. Additionally, Tigris has various functionality to make it easier to retrieve the data that you want for various census data sets. For example, if you want zip codes for a specific area. Now, as I mentioned before, zip codes in some cases cross state lines. And so the Census Bureau only makes zip codes available for the entire United States. You have to pull in the entire file. And so in the ZCTA's or ZICTA's parameter, if you're pulling zip code tabulation areas, and so just a heads up, zip codes are commonly used to sort of geographically identify data, but zip codes themselves aren't actually geographies. They're just pointers used by the US Postal Service to guide mail routes. The US Census Bureau creates something called zip code tabulation areas to approximate the geography of zip codes as best as possible. And so there is going to be, at times, a disconnect between an actual zip code. Some zip codes don't even have a physical area, and zip code tabulation areas. But if you need that type of data, you can use the starts with parameter and supply a string representing kind of the first digits of the zip codes that you want. Let's say I want the zip code tabulation areas for the Fort Worth, Texas area that start with, in many cases, 761. This is what I get back when I plot it. Additionally, I mentioned before we have, again, our legal entities, our statistical entities, and our geographic features. Roads are an example of a geographic feature that's available from Tigris. And roads are available for download from the Census Bureau by county. And so here's where we use that smart state and county lookup to call the roads function. We want the roads for Loving County, Texas, which is a very sparsely populated county in the west of Texas. And we call the first argument we supply is the name of the state. The second argument we supply is the name of the county. And we can get roads data for Loving County. And so one thing that we can observe as well is when I call that function, we notice that we look up the data, and then we have this object Loving of class spatial lines data frame. And so we can take a peek at the data slots in our studio, and we see we have a column called full name. We have different road types. And so if you wanted to grab a single road for plotting or for analysis or what have you, you could go through and you could take a look at which roads are in there. In Loving County, it's very rural. A lot of these are unnamed sort of country roads. But if you need, say, County Road 300, you could subset your data using normal subsetting functionality, the same way you would work with any spatial object. Additionally, at times, you're going to want data that might be distributed across multiple census data sets. As I showed you before, census tracts are only available by state. But let's say you want to do an analysis for a metropolitan area. Metropolitan areas frequently cross state lines, like the DC metropolitan area. So you might want to start out by grabbing census tract data and then combining them for Washington, D.C., Maryland, and Virginia, as just an illustrative example here. And so what I do is I create a vector of the 3 states that I want, D.C. as a state equivalent, assign it to this STS variable, and then I supply it to this rbind Tigris function. This is a function that allows you to basically row bind Tigris objects that come from Tigris together. And so rbind Tigris will check to make sure that all of the objects that you're trying to put together are of the same Tigris type. You can't put together counties and tracts, but you can put together tracts from different data sets. And so what we do here is we feed a little kind of function wrapped in lapply here to iterate through our vector, call the tracks function for each element of that vector, store the result in a list, and then rbind Tigris will combine all of those objects in that list. And so we can see this is the result that we get back. We've got all of the census tracts for Virginia, Washington, D.C., and Maryland. From there, again, you could go in and you could subset your tracts accordingly, or you could introduce some additional code. I just wanted to keep it simple here to subset that on the front. Tigris also includes a helper function named geojoin that tries to provide some functionality for merging tabular data to spatial data. And this is going to be a very common use case of Tigris in that if you're going to pull spatial data, ultimately, you're probably going to want to make a map with it or merge some statistical information to it so that you can do some analysis. And so you can go through the help pages of Stack Overflow. Merging data to spatial objects in R is not always straightforward. And so I wrote GeoJoin to try to streamline the process a little bit. And so in this case, we show a workflow in which we're trying to create a simple color-coded map that shows which state legislative districts for the Texas House of Representatives are represented by Republicans, members of the Republican Party, or members of the Democratic Party. And so we can pull in a couple toy data sets here. We'll create a data set named DF that represents the result of a read.csv call for a data set I'm hosting on my personal website. And then we'll make a call to this state legislative districts function. And so we have 2 data sets here. We can take a peek. And so our data frame here, DF, we see we have the name of the representative, the district they represent, the city if applicable, and then the party, D for Democrat or R for Republican. We can then also take a peek at the district's data slot. and see if there's a column on which we want to merge. And so the name column here is equivalent to this district column here in our data frame. So those are going to be the key fields on which we're going to want to merge. And so what GeoJoin allows us to do is supply, the first argument is going to be your object of class, could be likely spatial polygons data frame, but object of class SP. Your second argument is going to be a data frame that you want to merge. Your third argument is going to be the name of the field that you're using for the merge in the spatial data frame. And the fourth argument is going to be the name of the field that you want to use for the merge in your tabular data frame. We run the GeoJoin function, and then we can peek ahead, peek at the data slot. And we see that we've now merged our data. And from there, we can use base R plotting functions to generate a map. And so now we have a simple map that shows blue areas largely along the US-Mexico border and in major Texas cities like Dallas, Fort Worth, Houston, Austin, and San Antonio that tend to be represented by Democrats, and rural and suburban areas that tend to be represented by Republicans. So here's our results again, a little bit bigger. Now I want to show you, we're going to get a little bit more advanced with the workflows. And I want to highlight a package called TMAP. And if you haven't heard of TMAP, you should. It is an amazing package for cartographic visualization of data in R, and it is remarkably flexible. And it works great with Tigris. And so I mentioned this before, commonly when you're working with Tigris, Tigris is nice for pulling in data, but it's going to need to talk to other packages as part of your workflow, whether it be our suite of spatial analysis package or cartographic visualization packages or data packages to really get your work done. And so I'm going to use a GitHub package called Census API by Hannah Recht. And this package is a package, there are multiple packages that allow you to get data from the Census Bureau API. The Census API package, however, is particularly cool because it allows you to access all of the APIs. And so the Census API package will use that. We'll use the get census function to get some data. And what we're trying to get here, we're making a map of median home values for owner-occupied homes in the Chicago metropolitan area. Now, the Chicago metro area is larger than just Illinois, but just to keep things simple, we're going to focus on the counties in the Chicago area that are in Illinois. So I'm going to pull in some packages here, the Census API package, the tidyverse package to get us access to tidyverse functions, and the TMAP package by Martin Tenekis for thematic mapping. So I'm going to define a vector here of counties for which I want to pull data, and I'm going to supply that vector of counties to the tracks function. I'll also specify that the state is Illinois, and because I'm doing thematic mapping, I'm going to set CB to true. To reproduce this code, you're going to need an API key from the US Census Bureau. In the examples.r script, I provide a link for where you can get that. And then we'll make this data from this call to get census, assign the result to this data from API variable. So I'm going to go ahead and run this code. So now that I have the data, what I'm going to want to do is I need to transform the data a little bit, because you can take a peek at the data from API. And we have the tract ID kind of split across three columns, state, county, and tract. And then we have sort of a long census code that we supplied to the get census call B25077 underscore 001E, representing the estimate for median home values for census tracts in the Chicago area by tract. And so what I'm going to do next is I'm going to use the tidyverse function transmute to create a new column that concatenates state, county, and tract named GeoID, which will match with a column in my census tract spatial polygons data frame. I will create a new, functionally this is like renaming it because I'm using transmute, but I'm going to create a new column named value. And I'll assign my kind of median home value column to that new column. And then I'll supply that to the GeoJoin function, which you'll notice here, if you are matching columns with the same name, you can specify simply just that column. But you have to do it as a named argument saying by equals here, GeoID. We can then supply this to the tmShape function and string together a variety of other functions to make our map. Tmap works in a similar fashion to ggplot2, stringing together functions with the plus operator. And so let's go ahead and run this code and see what we get back. We have a kind of functional static map that shows the distribution in the Chicago area. And for reference, if you're not familiar, the downtown Chicago loop is right about here. And so median home values, the darker greens, we see higher values on the north side of Chicago and the North Shore suburbs, lower values on the west and south sides of Chicago, and kind of scattered throughout, especially in some of these satellite cities like Elgin, Aurora, and Waukegan. As a cartographer, you might want to do more with this and add some information like roads or place names to orient your reader, but this is a good start. But one thing that is really cool about tmap is the function. Here's a better view of our map if it's a little bit small in our studio. One thing that's great is the function ttm. TTM converts tmap into interactive viewing mode and allows you to specify tmap code, but create an interactive leaflet map using the leaflet R package from your data. And so I'm going to run this code here, and if I specify TTM, change tmap mode to interactive viewing, and then supply the same tmap code, notice what I get back. An interactive, zoomable, pannable leaflet map that allows for further interactive exploration of my data. I can zoom in here to the north side of Chicago and click on any of my polygons, any of my tracks to get back a pop-up showing the value. So for this census tract, the median owner-occupied home value is just over $600,000. Now, in the time we have left, I want to chat briefly about some recent functionality that's been added to Tigris, which allows you to return the results of Tigris function calls not as SP objects, but rather SF or simple features objects. And simple features, the package itself is relatively new, but it represents the future of spatial data in R. It is extraordinarily exciting. It represents spatial data as basically R data frames with feature geometry stored in a list column, which is a column of your data frame that for each row of the data frame stores the feature geometry for that particular feature. I don't have enough time to go into all the specifics of the SF package, but I encourage you to check out Ezra's documentation. He's the core developer of the package, which is amazing and really will revolutionize working with spatial data in R, in my opinion. So take a look at that link and learn more about it. In Tigris, there are two ways to return objects of class SF. You can add class equals SF to your Tigris function call, or at the beginning of your script, you can set this globally with the call to options Tigris underscore class equals SF. So the cool thing about SF, or one of the many amazing things about SF, is it allows you to use tidyverse verbs to work with spatial data. which means that your spatial analysis workflows now can look a lot like your regular tidyverse pipelines that so many of us use to work with data in R. And so we can ask an exploratory data analysis question like, here, how do home values in the Chicago area vary with distance from downtown? We've already mapped it out, so we get a general sense of where hotspots of high and low values are. But in a general sense, is there any relationship between, in an exploratory sense, distance from downtown and home values in a census tract? And so what we'll do is we'll create a simple features object here named City Hall, where I supply the longitude and latitude coordinates of Chicago City Hall. We'll use that to represent the city center. And then in a pipeline, we convert it to simple features geometry with the st_point function. We then convert it to a simple feature collection where we can specify the CRS using common EPSG codes in R, supplying that to the CRS parameter. I should mention the data, when you pull in data from Tigris, it uses the geographic coordinate system NAD 1983, which most of us are familiar with working with the WGS 1984 coordinate system. NAD 1983 is very, very similar. In some cases, it'll be a meter to a meter and a half off from WGS 1984, but for thematic mapping purposes, those differences will be negligible. We then transform our City Hall point to an appropriate projected coordinate system for distance calculations. We're using here UTM zone 16 north, and the code here is 26916. We then can create a pipeline, and I'll walk through this a little bit. We set our Tigris class to SF. We make a call to the tracks function, which will now return an object of class SF. And I will show you what this looks like. I'm going to go ahead and run this little piece of code. So we'll load SF. We'll create our little City Hall point, and then we'll load in our Chicago tracks, but we'll assign it to the variable shy_tracks_SF. Now we can take a peek at that object, and we notice here it looks a lot like a data frame, but it understands coordinate system, and it has this column named geometry that encodes the feature geometry for each census tract. From there, what we can do is supply this to sort of a tidyverse style pipeline in which we can walk through these different functions. First and foremost, if we want to know how home values vary by distance from downtown, and we're going to do a Euclidean distance, just a linear distance computation here, which means we need both of our data sets to be in the same projected coordinate system. We use the st_transform function to transform to UTM zone 16 north. Notice here we use left join to join our home values data. Left join being a dplyr verb. We don't need geojoin anymore. Geojoin still works. I rewrote it to work for SF objects, but we don't need geojoin anymore from Tigris because the dplyr join verbs have been written in SF to work for simple features objects. So we merge back in, we join back in our home values, and then we create a new column using the mutate command named dist. That's the result of a couple SF functions. We're converting to numeric here, but what we're doing is we're taking the distance between the centroid, so the central point of each census tract polygon, and City Hall. And so the value of the dist column will represent that distance. We then pipe that to ggplot and create a basically a low S smooth kind of a scatter plot smooth chart of how home values vary by distance from downtown. We can run this pipeline code, and we get a chart like this. In an exploratory sense, we can use this chart to start to think about general trends in the Chicago area. Now, if you're wanting to present this to people, you want to obviously clean up your ggplot. But here we see that home values, as estimated by the lowest smoother, they tend to be highest nearest to downtown. They drop off about 12 to 15 or so kilometers from the urban core. They rise again about 25 kilometers out, and then start to fall off again when you exceed 50 kilometers out. And so kind of another way of using spatial analysis techniques with SF, and we notice how fast that all went once the code is written, to think about general trends, a house price gradient, if you will, or a home value gradient in the Chicago area. You can even, with simple features, now supply objects of class SF to ggplot2, and I believe this functionality right now is just in the development version of ggplot2, but I'm sure it'll be up on CRAN soon if it isn't already. And ggplot2 has a new geom called geom_SF, which allows you to plot SF objects directly. And so I'm not going to go through all of the code that generated this plot, which is a dot density map. If any of you saw the Esri dot density maps comparing households with incomes, or kind of areas, households with incomes above 200,000 with households of incomes below 25,000 to look at income inequality in cities. This is a replication of that using R. All of the code is in that examples.R script. And we can see in the District of Columbia, Southeast DC, a preponderance of low-income households. Northeast DC, you see a preponderance of high-income households. And again, I'm not going to go through all of the code here, but what you'll be able to see if you're walking through that code is how simple features allows you to build maps like this, often in pipelines, the way that many of us Tidyverse fans are accustomed to working with data, and then use ggplot2 without having to fortify a spatial data frame, but plot the data directly using ggplot2. And so that's what I have for you today. I would love to hear from you. I'd love to get your feedback and learn a little bit more about how you're using the package. I'm on the web in a couple different places. At my professional website at TCU is linked here. I also have a consulting page where I blog about various spatial topics, hosted on GitHub pages, and I like to tweet about this stuff, so give me a follow if you're interested. And so, Ari, that's all I've got. Happy to open up for some discussion.
Kyle, that is fantastic. Thank you so much. Why don't you turn on your camera as well if you can? So, or actually maybe if you turn on your camera, I wonder, we definitely want people to see those links. I have one brief question, because as you know, I've done a lot with mapping and ACS data, and I have previously, all of my work uses the ACS package. It looks like you were using a package called Census API that I hadn't heard of before. Can you tell me a bit about that?
Yeah, the Census API package, it's fairly new, and let's see if we can grab a little bit info about it here. I'm gonna pull over the GitHub repository here. We'll take a look. The Census API IR package, it's not up on CRAN, it's just on GitHub. It's by a developer named Hannah Recht. She used to be at the Urban Institute. I believe she's now at Bloomberg. And she is a really, really talented R developer who created this really cool package to talk to any of the Census APIs. And so ultimately, if you're using the ACS package, the ACS package is really feature complete and has a lot of functionality for working with ACS data. The Census API package, I think the advantage to it, it's not as feature complete, and you'll notice in the function calls, you'll have to specify kind of a little bit of the information that's going to feed ultimately into the API call to the Census Bureau, but because it's generalized as such, you can get data from any of the APIs that you want, so long as you know what you're looking for, and it directly returns our data frames, which I thought was useful for the purposes of illustration here, because I wouldn't then have to wrangle the data to get it into a data frame,
Got it.
to save a step.
So that makes, and you
So
said it's not on CRAN yet, you said.
it is not on CRAN yet, but it is available from GitHub. And so just search Census API for the GitHub package and take a look at it. I think it's only got 18 stars. I think it deserves quite a few more stars than that. And so feel free to star it and take a look um, and give it a test run.
We have a question here. If you go back to your last slide, you give some links. Some people
Yes.
are asking, can you include a link to the examples.r file here? These are links to your websites.
Yes. Let me go all the way back to the beginning.
Oh, in the beginning. Got it.
Where you're going to find examples.r is in the GitHub repository. And so if you search for on GitHub, Tigris webinar, or follow this link, so I'll go ahead and pull it up here.
Can you copy and paste the link into the chat?
I absolutely can. And so let's plug this in here. Here's the GitHub repository in the chat. And then I'm going to send a link as well directly to the examples.r script. So you can go straight to it. So here's the direct link to the examples.r script. And that includes all of the examples that we covered today.
That's great. And I have the email address of everyone who registered, so I can also include that there, because I know that everyone loves to play with the code. I mean, that's a great learning tool. So I'll
absolutely.
make sure that everyone has access to that.
And I would love to see people experimenting with it. And if you come up with something that's interesting or build upon some of this stuff, let me know. I would love to hear how people are using the package. And I encourage all of you to take a look at, if you hadn't heard of Team App or if you hadn't yet used SF, take a look at it. These are some very exciting developments.
If people do create something that that they're happy with and they want to share it with you, is Twitter the best way to get in touch with you?
Twitter's great. Send me an email as well. But Twitter is great because you can share it then with more than just me. You can share it with lots of people. I'll give you a retweet, and you can get a little bit of an audience for your work.
Fantastic. Are there any other questions? I know that we need to end soon because we're near the end of the hour, and I'm sure you've got other things to do. But are there any other questions just before we go?
Yes, please ask if anyone has questions.
Great. In that case, I think I will end the webinar. I'd like to thank Kyle again for coming to give this presentation. I've been really interested in tigers for a while, and I know I certainly got a lot out of it. And from the chat comments, it looks like a lot of other people did as well. So thank you very much, Kyle, and thank you everyone for coming.
Thanks, Ari. I appreciate it. And again, thanks to all of you for listening. And again, feel free to send along any feedback or share with me how you're using the package. So would love to hear from you.
All right.